Oh, sorry. I don't know that your talk ends so fast, so I'm not very well prepared. Sorry. Uh, okay. Hi, everyone. My name is Huishan Zhao. I'm from Tsinghua University in the Department of Mechanical Engineering. Thanks for Professor Fumie Ida and the organizers for inviting me to join this very exciting conference. And I think this conference makes me to rethink about my own research. So it's a very good chance for me to have this presentation with all of you. So basically, there are many challenges for robotics, but for me, I think there are two which is very critical that are limiting robots to be more widely used in our daily life and our industry. For example, they have very limited adaptability if they're in some extreme environments. For example, those very crowded environments or those very narrow spaces. So we have to redesign the robots into some special shape and then control it to a very high level of autonomy to go into these environments. Another important thing is that we want robots to get close with humans and work with us, but the safety becomes very, very important when getting closer with humans. So basically for me, I think embodied intelligence is a great way to solve the above two challenges. However, I think in this conference, mainly that there are two types of intelligence. The first one is mechanical intelligence, and the other one is more like Yuki's work, is like the computational intelligence. For my research in the past many years, I've been focusing on the mechanical intelligence of robots. Sorry, this one is like a bit hiding my slides. Okay, so for this mechanical intelligence, there are many advantages. For example, they are very simple. You simply change the compositional material of your robot into some material with compliance, with inherent compliance. And then you will get these kind of mechanical intelligence. For example, a soft gripper can adapt to the shape of the object autonomously without any sensors and controllers in the system. Another way is it is very reliable. So we don't need a computer to compute everything for us. And the system will automatically showing its intelligence. The other two important advantages is like its low cost and low energy consumption. Many of my previous work, if I say it from an intelligence point of view, is all utilizing the mechanical intelligence of soft materials. For example, we have built some soft prosthetic hand that can grasp things with a gentle and very safe manner. We have some exoskeletons that can be worn on the human's hand, but don't disturb people's normal motion, as well as don't have any risk of hurting a person. We also have some bio-inspired like mobile robot that has a bio-inspired shape that can go onto the terrain and adapt to the shape of the terrain, such examples. Here I will have another more close examples to share. The first one is we have built a material called artificial muscles, which is based on a dielectric elastomer actuators. The electrostatic force will generate a deformation for the material. And this material has a very special characteristic, which is it can self-clear itself, which means, for example, it is experiencing a large strain or even some cutting, some damage during its operation. It can it can heal itself and keep on functioning. So when we apply such materials to build an insect-sized robot, this robot is very robust. For example, during its flying, if it accidentally drop onto the ground or fly into the wall, because the material is very robust and can be self-healed, the robot also is very robust. So this is one example. So recently, we also built a robot to get into this kind of tiny pipes for inspection. So the robot looks like this. And we build a prototype. It looks like this. It can fit into diameters of less than 1 centimeter, this kind of pipes. We don't have any very complex mechanism for it to adapt to the complex shapes of the pipes. Simply by utilizing its soft body, it can go into complex shapes like this L shape, S shape, and a spiral shape without any mechanism or control mechanisms. So this is another example. So basically, soft materials can facilitate a robotic system with good toughness and good compliance. Some other advantages like the soft materials can by itself amplify the force-induced deformation so that the sensing can also have better sensitivity. But later we found that soft materials are not always as adaptable as we expect it to be. For example, this kind of grasping, when we use a soft gripper, a soft finger, this kind of typical bending finger to grasp an object, for the small size diameter cylinder, it can adapt to the surface of the shape quite well. But when we get a larger diameter object, you can see that they don't adapt to the shape that well. They only result in a contact point so that the grasping force is not that large. So how we solve this problem is we get some inspiration from humans and embedded this soft finger with a rigid skeleton. And we use a camera to catch the shape of the object and let this finger to decide what kind of shape the finger should be like, and then use this strategy to grasp object. And in this way, it can adapt to the shape much better than a totally soft and totally passive way. So this makes me think that perhaps in the future, we should also look at the computational intelligence for soft robot to further increase its adaptability and safety. But the challenge is, But the challenge is different from a typical robot. For a software robot to achieve this kind of computational intelligence, we also need to find the correct sensors, the powerful sensors and the powerful actuators for it compared with a traditional robot, because we don't have that on the shelves. So in that way, we have to build a different kind of soft sensors to facilitate a robot with already the powerful perception capability to achieve this perception, plan, and decision cycle. This is some work we recently been doing, like we build up a small soft sensor that can sense different forces from different directions. And in such a way, we can put many of them on the skin of a soft robot to facilitate with good perception capabilities. But this example is showing it put on the rigid robot. Another important thing is soft robot experience very complex geometry during his deformation. So in that way, we have to reconstruct this very complex 3D shape in real time. And in this work, we have been embedding like the IMUs and also the frag break grating sensors into a soft body to trying to in real time reconstruct the shape. So this is some basic functions to achieve the future computational intelligence. And I hope that in the future we can plus mechanical intelligence and computational intelligence to take over both their advantages and build a more adaptive and safe robot. Okay, thanks for listening.
Thank you so much, Huichen. You already gave the great answer to my question, how we can bridge the gap between the mechanical and the computational intelligence. Thank you so much.
Okay,
then let's move to the third talks by Dr. Amy Shakes.